Welcome to today's session on probability. So in probability, we are going to look at problems on simple events. Okay. So we learned what is probability. So probability of an event E is number of favorable outcomes, number of favorable outcomes by total number of outcomes. So total number of outcomes. So that's the formula for probability of E. Or in other terms, we can write this as P of E equal to N of E by N of S, where N of E is the number of times that favorable event can happen by total number of outcomes. Okay, now let's look at some problems here, right? Problems on pack of cards. Okay, so we'll frequently get problems in board exams on the pack of cards. So first we need to understand the pack of cards structure, right? A, a pack of cards basically consists of 52 cards of 13 each. If you follow me, right? They are divided into 4 groups basically. So pack of cards are divided into 4 sets or groups. So 13, there are 13 cards which we call as spades, right? And then diamonds, spades, diamonds, clubs, spades, diamonds, clubs, and there is another category. Let me check. So they are divided into basically 13. 13. So if there are like 52 cards, each set is 13 cards, and that are spades, hearts, diamonds, yeah, and hearts. Okay. So hearts are of this shape, the cards, if you are familiar with the pack of cards. And then we also have clubs. Clubs will be like kind of a leaf, right? So those are clubs. And we also have diamonds. Diamonds are just like a rhombus symbol here. And also we have spades. Spades are like these three, right? So it's like this. Okay. So the pack of cards are divided into 52 cards. Pack of cards consist of 52. Those 52 are divided into 4 sets, spades, diamonds, clubs, and hearts. So here there's a color as well. The spades are black in color and diamonds are red in color. The cards are red. Everything printed on the card is in red form. And clubs is also black. And then hearts are in red color. So diamond and hearts are in red color. So total how many red card colors, red cards are there? 26. And how many black cards are there? 26. And spades 13, diamonds 13, clubs 13, and hearts are 13. And now out of these 13, these cards are in the form K, Q. K means king, queen, jack, and then 10, 9, 8, 7, 6, 5, 4, 3, 2, and one is, we call it as a ace. Okay, so out of this, king, queen, and jack are called face cards. Means that will have face printed on it. So king, queen, jack are face cards, and the others are numeric cards, and A, the last one is ace card. Like that, every 13 have those denominations, right? K, Q, J, and then the numerics 10 to 2, and then A. The first card is A, which is ace card. Okay. So this is the structure of pack of cards. So the pack of cards consist of 52. Out of 52, they are divided into 4 sets: spades, diamonds, clubs, and hearts. Now, the black The black color cards are two, spades and clubs. The red colors are diamonds and hearts. Okay. Now, based on this, we will see what kind of problems we will get, right? So, if you see here, problem on pack of cards. One card is drawn from a well shuffled deck of 52 cards. Okay. So, always remember in a pack of cards, n of s is total outcomes are 52 because there are 52 cards. Okay. Find the probability of getting a king of red color. A king of red color. So probability of getting a king of red color. King of red. I'll just denote like this. This is what is the probability? N of getting K by N of S. What is the probability of getting a king card? Let's look at our setup right here. So how many king cards will be there? There will be four king cards. But what was asked? Probability of getting a king of red color. So how many red color cards are there? Two sets, right? So this is one, sorry, here, right? Here one king card and here one king card from the diamonds and hearts. So that means two king cards are possible. So this is 2 by 52. Understood? This is how we can solve the problems. For example, second, what is the probability of getting a face card? So how many face card will be there? Probability of getting a face equal to n of face by n of s. N of face. Let's see how many face cards are there. 1, 2, 3. Three face cards are here, right? So there are how many face cards? Let me check. King, queen, and jack are called the face cards. Yeah. So three from each set. So that means three here, right? K, Q, J. Here also K, Q, J, K, Q, J. These are the face cards. So total face cards are three in each set into four sets. That means 12. So here n of getting a face card is 12 possibilities by total are 52. You can simplify or you can leave as is. So if you want to simplify, you can write this as 2 ones and 2 26. That is 1 by 26. Here also with 4 you can do, I guess, right? Yeah, 4 threes, 4 ones and threes. So 3 by 13. Or you can just leave 12 by 52. That should be okay, right? Now similarly, third one. What is the third one? Getting a red face card. Probability of a red face card. So let's go back again. So how many red cards are there? Two sets. Out of two sets, how many face cards are there? Six, right? Three in diamonds and three in hearts. So it is 6 by 52. Understood? Similarly, the fourth one, the probability of the jack of hearts, probability of J of hearts. How many heart cards are there? 14. Out of 14, how many jacks are there? 1. So the probability is 1 by 52. There is only one jack card, which is from the hearts. Understood? So 1 by 52. Now, next, the fifth one, the probability of getting a spade card. How many spades are there? 13, right? So if you get any card from the 13, then that is your favorable outcome. So 13 by 52, that is. You're following, right? Next, the last one here. Then the queen of diamonds. Okay, so the probability of getting a queen of diamonds. So how many diamond cards are there? 13. Out of the 13, how many queens are there? Only one. One queen is there. 1 by 52. Hope you understood, right? So these kind of problems you will get uh, from the pack of cards. So basically what you need to understand is from the pack of cards, the structure you need to know. So the structure is 52 cards divided into four sets: spades, diamonds, clubs, and hearts. Spades and clubs are black, diamonds and hearts are red. And then you have three face cards, K, Q, J, and then you have numeric cards, 10, 9, 8, 7, 6, 5, 4, 3, 2, and there is an ace card. Similarly, you have in the every group, every set, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, and then ace card. 10, 9, 8, 7, 6, 5, 4, 3, 2, and ace. So if they ask for the face cards, each set has 3 face cards, K, Q, J. Total, you will have 12 in a pack of pack of 52 cards. So what is the probability of getting a face card in the entire set is 12 by 52. What is the probability of getting a face card of diamond? Means 3 by 52, because in each set you will have 3. Likewise, the problems will be asked. Okay. All right. So let's move on to dice problems. Okay. You know the die, right? So that we will play. That's like a 3D shape. You guys know this, right? So this is a dice. So it will have dots. It will have dots on that. 1, 2, like that. So when you roll a dice, we will see if you roll a single die, what is the, yeah. If you roll a single die, what outcomes are possible? If we roll 2 dice, what outcomes are possible? Let's say if we are throwing a single die, then your sample space S can be, you can get 1, you can get 2, 3, 4, 5, 6. A total of 6 possibilities. So N of S is 6. Then they can ask various questions like what is the probability of getting 4, right? There is one possibility. So 1 by 6. What is the probability of getting 6? So when you throw a die, there is only one possibility where you can get 6. So 1 by 6, like that. Now, what happens if you throw 2 dice? If you throw 2 dice, this sample space becomes huge, because it is, here you can get 1, there you can get 1 or 2 or 3 or 4 or 5 or 6. So it is like 6 times of 6. So 36 possible outcomes are there. Okay, 6 square outcomes are there. So how to find those outcomes? So I'll give you a hint. Okay, so let's say, listen this carefully. This will be very helpful for you remembering this trick. How to solve the problems with dice. Then 1, 2, 3, 4, 5, 6. So I am considering 2 dice. This is 1 die and this is 1 die. Okay. So if I throw, there is a possibility I can get 1 comma 1. There is a possibility I can get 1 comma 2. This die can get 1 and the other die can get 3. Similarly, 1 4 is one possibility, 1 5 is one possibility, 1 6 is another possibility. You following me? So on one dice you can get 1. On the remaining dice you can get, on the other die you can get either 1 or 2 or 3 or 4 or 5 or 6. So total 6 possibilities are there by fixing 1 on the first die. All total outcomes we are trying to get, right? So here the other possibility is we can get 2 1, 2 2, right? 2 3, 2 4, 2 5, and 2 6. This is other 6 possibilities. If you have 2 on the first die and on the other die, there are other 6 possibilities. Similarly, this can be 3 1, 3 2, 3 3, 3 4, 3 5, and 3 6. This is another 6 possibilities with 3 on the first die. Similarly, you also have 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, and then 5 1, By now, I think you know like how to write this table, right? If you get a dice problem, what I suggest is first you draw this table and then solve whatever is given. So I'll help you like how to read this table and get to the required probability. 6, 3, 6, 4, 6, 5, and 6, 6. So total, how many? 6 into 6, 36 possibilities. So if 2 dies, this is the sample space, right? The sample space is 36. So the total N of S is 36 here. For a single die, N of S is 6. For 2 dies, the N of S is 36. Now, what kind of problems will be asked? So what they will ask is, what is the probability of getting a sum of 2? Getting a sum of 2 on both the dice means on the first die I should get 1, on the second die also I should get 1. So this you need to add. 1 plus 1 is 2. So there is a single possibility, right? There is a single possibility to get that, right? So 1 by 36 we can say. They can ask what is the probability of getting a sum of 3 on both the dice. Right? Sum of 3 means what is the possibility? This, if you see here, so this is the these two are the possibility of getting 3. 2 plus 1 is 3, 1 plus 2 is 3. So 2 by 36. Similarly, if you look at diagonally, the sums are same. 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So what is the probability of getting a sum of 4 is 3 by 36. You're following? And then what is the probability of getting sum of 5? So there are 4 possibilities. So 4 by 36. You following? And then if you look at here, what is the sum of getting 6? There are 5 possibilities. So 5 by 36. Similarly, the maximum count you can get is, we will see. So this is for sum of 6, not 6, 7. So what is the probability of getting a sum of 7 is 1, 2, 3, 4, 5, 6 possibilities. Then what is the probability of getting a sum of 8? 8 is how many? 4. So 4 by 36. Similarly, this is 9. 9 means how many? 1, 2, 3, 4. 4 by 36. And then 10. 10 is 3 by 36. The sum of getting, what is the probability of getting a sum of 10 on both the dice? Sum of 11 is 2. And then sum of 12 is only one possibility. Getting either one, getting a sum of 2 is one possibility. Getting a sum of that 12 is one possibility. And the remaining you can see here. If you put it diagonally, you can count like the different combinations. So that's why I taught you this table. This table is very important and you can solve any problem on a dice. If 2 dice are thrown, whatever the problem they can give, you can solve using this table. Okay, so in the next, let's have a look. What kind of problems can be asked here, right? If you look at here, in this, we need to fill this, okay? Event is sum of 2 dice. So when we throw 2 dice, you will get one number on first die. There is another number you will get on second die. So if we add the two numbers, whatever we get, so that should be this is sum. This is sum. So here they're asking what is the probability of getting 2, that they have already denoted 1 by 36. And we also know there is only one possibility of getting a sum of 2. Now here, see, what is the sum of 3? Sum of 3, I think we already know the 2 possibilities, 2 comma 1 and 1 comma 2. So this is 2 by 36. You're following, right? And then what is sum of 4? 4 is this 1, 2, 3. 3 possibilities. So it can be 3 comma 1, 2 comma 2, and 1 comma 3. So can I say this is 3 by 36, right? 5. 5 means this one. 1, 4. Yeah, this one. 4, 1, 3, 2, 2, 3. So 4. So 4 by 36. This is given in the order, so we can straight away write. Okay, and then sum of 6. 6 is this 1, 2, 3, 4, 5. So 5 by 36. Then sum of 7. 7 is 6 comma 1, 5 comma 2, this row, this diagonal, right? How many are there? 1, 2, 3, 4, 5, 6 possibilities. So 6 by 36. And then 8 is already given. We know 1, 2, 3, 4, 5 possibilities. Then 9 is 1, 2, 3, 4 possibilities. So 4 by 36. And then getting a 10. Getting a 10 is 3 possibilities. So 3 by 36. And getting 11 is 2 possibilities. So 2 by 36. You can simplify. 2 by 36 means 1 by 18 you can write. Okay. So these type of problems will be asked. They may not ask like a table. They can just ask like what is the probability of getting 9 when 2 dice are thrown. So just draw the table and from that you can count. 9 means this diagonal. 6, 3, 5, 4, 4, 5, 3, 6. So you can just say that. You got it, right? So that's how you can solve the problems on a dice. This is very easy if you know how to draw this table. Okay, so that's on the dice problems. Now let's look at some generic problems. What can be asked, right? So let's look at this problem. A lot of 20 bulbs contains 4 defective ones. So there is a group of bulbs, a set of bulbs, right? And there are 20 in that set. Out of the 20, 4 are defective. Okay, that means 16 are good and 4 are defective. One bulb is drawn at random from a lot. If we draw one bulb at a random, what is the probability that this bulb is defective, right? So what is the sample space here? N of S, right? Total bulbs are 20. Now, what probability we need to find? What is the probability of a bulb getting a defective one? So I'll just write probability of defective equal to N of defective. Can I write that? N of getting a defective bulb. I mean, how many possibilities are there to get a defective bulb by N of S. N of S is total sample space, which is 20 bulbs here. So what is N of defective? How many defective bulbs are there? 4. So if I get any bulb from the defective, then that's a favorable outcome for that event, right? So how many such are there? 4. So the total favorable outcomes to get a defective bulb is 4 by 20. That is 1 by 5. Understood? Now the second one. The second one is, suppose the bulb drawn in, right, is not defective and is not replaced. So in the first problem, a bulb was drawn. What is the probability of getting drawing a defective is 1 by 5. Now, in the second scenario, that bulb was drawn and that bulb is not a defective. Okay. So that means in the second scenario, N of S becomes, and that bulb is not replaced. That means N of S becomes 19, right? Total sample space, because that one bulb was drawn and kept aside. That means the total number of bulbs in the lot or the set becomes 19. Okay, out of 19, how many defective are still there? There are still 14 are defective because, sorry, 4 are defective. How many defectives are there? 4, because the bulb that was kept aside was not defective, right? And then how many goods or good will be there? 19 minus 4. There are 15 good bulbs are there, right? Then now one bulb is drawn at a random from the rest. Means from the 19 bulbs, there is another bulb drawn. Then what is the probability that it is not defective? Not defective means the probability of not defective is N of not defective, or you can just write like E is the event of not drawing a non-defective bulb. Then you can just substitute P of E equal to N of E by N of S. That also you can do. For our understanding, I'm just writing this. Non-defective means a good bulb. So how many good bulbs are there? There are 15 good bulbs by 19. Understood? So this is the probability of not getting a defective bulb when in the first scenario, one bulb was drawn. If it is not defective, that was kept aside and another bulb was drawn from the remaining. So here the sample space becomes 19. That is key. We need to remember it is not 20 because one bulb is kept aside. So out of those 19, there are still 4 defective because the bulb that you initially drawn was not defective. That means the defective bulbs are still in that lot. So four defective bulbs are there. That means the good bulbs are only 15 now. Earlier it was 16. One bulb was done and kept aside. So they became 15 now. So 15 by 19 is the probability of getting a good bulb or not defective bulb. Okay. So these type of problems can be asked. Okay. All right. Yeah. Let's look at another one. So here a lot consists of 144 ball pens. Listen carefully. Similar problem. I am just giving another example. A lot consists of 144 ball pens, of which 20 are defective. Okay, so total 144 pens are there, 20 are defective, and the remaining are good. So here can I say n of s is our total sample space, that is 144, and n of d, I would say d as defective, which is 20, and n of g is good. Okay, so how many? 144 minus 20 means 124 are good bulbs. Okay, d is defective, number of defectives, and number of good. Okay, now Nuri will buy a pen. So some person Nuri will buy a pen if it is good, but will not buy if it is defective. Okay, so there is a lot of 144 pens. Out of 144, 20 are defective. There is a person Nuri who will buy only good pens. If it is defective, she will not buy. Okay. The shopkeeper draws one pen at random and gives to her. What is the probability that? Okay. You understood, right? A shopkeeper has a lot of 144 pens. Out of 144, 20 are defective, and he just he just draw one pen and give it to Nuri. And we know the condition of Nuri is if it is good, then only she'll buy. Now, the probability they are asking, she, what is the probability that she will buy it? When she will buy, if it is a good pen. So, can I say probability of getting a good pen? Why? Because when it is a good pen only, she will buy. That she has already given. So probability of getting a good pen is n of g by n of s. What is n of g? There are 124 good pens by 144. Understood? If you want to simplify, then 4 threes, 4 ones, then 4 threes, 4 eights. No, 4 6, right? 4 6 24. So this is 31 by 36. Understood? So 31 by 36 is the probability of getting a good pen where Nuri can buy. Then number 2, she will not buy. She will not buy, we can do in 2 ways. So when she will not buy, if it is a defective, right? So probability of getting a defective pen is n of d by n of s. So what is n of d? 20. So 20 by 144. If I want to simplify, 4 fives, 4 threes, 4 6. So 5 by 36. This is one way. The other way is we already know probability of not buying, right? Probability of not buying is nothing but probability of defective, right? So the probability of defective, we can also get it using probability of not probability of good. If it is good, she will buy. If it is not good, she won't buy. So what is the probability of not buying is 1 minus probability of good. That is 31 by 36. If I substitute, that is 36 minus 31 by 36, which is 5 by 36. You got the same, right? So we can solve in 2 ways. Because we know how many defective bulbs are there. So we can straight away do n of d by n of s. So that is 20 by 144, which is 5 by 36. Understood? So in this chapter, to recap, right? So what we have seen a pack of cards, 52 cards divided into four groups, 13 in each group: spades, diamonds, clubs, and hearts. Spades and clubs are black colors, diamonds and hearts are red color. And then you have KQJ, and then the numeric and ace cards. So the face cards in each set is 3. So total face cards in that pack of 52 cards are 12. Okay. And then we saw how to solve the pack of cards problems. And then we looked at dice problems. So if it is a single die and two dice, this table is important. So as long as you put this table correct, you can answer any question. Okay. So this is the question we answered. And then a lot of pens or bulbs. They'll give some are defective, some are not defective. So what is the probability of getting a defective one? And what is the probability of not getting a defective one? That kind of thing. And this problem is very important. So here, what is happening is, unlike the other problems, there are two scenarios given. In the first scenario, from the 20 bulbs, if you draw one bulb, and that is non-defective, and that was kept aside. That means your total possible outcomes are now reducing from 20 to 19. That is very key. Okay. So if you get that, you can solve any problem here. So yeah, that's all for today's session. I hope you all understood the topic, and I'll see you next time. If you have any doubts, please contact me using my Urban Pro profile. Thank you.